and then we will see some of the PSC design features in the program. After that, I'll be discussing about some features that help the bridge engineers. So let's start. So MIDAS Civil is a 3D FEM software for bridges and civil structures. So as you can see on your screens that MIDAS Civil is capable of handling all types of bridges. You can handle the suspension bridges, the conventional bridges, the integral bridges using the program. Also, MIDAS Civil is capable of performing all kind of analysis varying from the simple static analysis to advanced analysis such as the construction stage analysis, the dynamic nonlinear analysis, and so on. So in the coming slides, we will be talking about the capacities and the major functionalities of the program. First of all, let's see a project application of MIDAS Civil. So here we have the model for Basarab overpass. This is located in Romania and it is one of the widest bridges in the Europe. The bridge is around 46 meters wide at its widest section and the bridge is around 1.5 kilometers long. The bridge is constructed using the free cantilever method. Also, Romania is a highly seismic zone, so the program was also used for performing nonlinear dynamic analysis with lead rubber bearings and viscous dampers. Now, let's discuss regarding the modeling philosophy as well as the features. So, whenever we need to design a bridge, we need to first idealize the structure of the bridge. Let's say we have a structure like this. So we need to idealize the structure. Now for the idealization of the structure, we have various options available. We can idealize the beam as a line beam model or a grillage model or a full finite element model. Let's discuss some pros and cons of all these three models. So first we have the line beam model. For narrow bridges, we can obtain accurate results in a quick way using the line beam model. But as the width of the bridge starts increasing, the line model fails to give the transverse distribution of the loads and the bearing reactions cannot be obtained accurately using this model. So for those cases, we have to switch to the grillage model. In the grillage model, we idealize the bridge deck through grillage of interconnected beams. So in the grillage model, we can get the accurate load distribution as well as the accurate bearing reactions. And then we have the full finite element model. Using the full finite element model, we get a more realistic structural response and it represents the local as well as the global responses more accurately. Today I will be using the line beam model for the demonstration purpose. Now let's see some of the modeling features in the program. So the program offers the general modeling procedure. Also for the bridges which are constructed through typical construction processes, the program offers various modeling wizards. So the program offers you a wizard for incremental launching method bridge. Also the program offers you wizard for the bridge which is being constructed through free cantilever method and full shoring method. Then we have the various other wizards like for the suspension bridge, for the cable stayed bridge. Then we have the grillage wizard which helps you in creating the grillage model. And then the transfer section wizard. We'll be discussing about these in the coming slides. So first we have the free cantilever method bridge wizard. So here you can see that once you input the information regarding the model, regarding the section and the tendon. Then the program will automatically model the bridge for you, and the program can also simulate the construction stages for you. Let's see how we can use the bridge wizards in MIDAS Civil. So for this purpose, I'll open a new model file. I don't have any predefined material or section information. I'm starting from a fresh file. So here in the structure tab, we have the FCM Bridge Wizard. Here I will open a file containing the values for these parameters. So now I need the material information for the girders as well as the piers. For that, the software has the database of the materials. Also, the program supports the import of the materials from the previously completed projects. So here I have 3 materials in my previous model file. So I'll import those materials. And then I need some section for the pier. For that, the program also supports the import from the previously defined projects. So I can make a selection that what sections I want to import and what sections I do not want to import. So here I have the information for the sections. This information was for the section for the pier, and now for the section for the bridge. So here I have some predefined shapes. So I enter the values of these parameters for height and the width, and the section will also be created. And then finally the tendon information. So I need to input the information like the jacking stress and the location of the tendons. And then I need a tendon property. I need to define my tendons. So I'm defining a tendon property. So all is done. Now as soon as I will click OK, the program will start modeling a bridge. So here we have the bridge with us. So here we can see that in the works tree we have the information with us. The program created the static load cases and the tendon profiles. And then also the construction stages. So here we can see that in the first construction stage, we have the piers and the deck above the piers. As soon as the construction stages are going ahead, the bridge is being installed. And as we move to the last construction stage, the installation of the complete bridge has taken place. So using the bridge wizards, it is very easy to model the bridges. Now, after free cantilever method bridge wizard, the program also supports the full shoring method bridge wizard. So similarly here, we can enter the information regarding the model, the section and the tendon, and the bridge will be modeled by the program. Now for PSE sections, we can have the NCEL sections, PSCI sections and PSCT sections. These sections are auto-defined in the program. So you can enter the values of height as well as width, and then you can model these sections. Also for database, the program supports the section database as per AASHTO codes, as per Caltrans codes, and the Italy as well as UK codes. So you can just select the section from these databases and use the section. Then if you want to have a user-defined shape, then you can import a DXF file using section property calculator, and you can create any user-defined shape in section property calculator and general section designer, and then use the shape in MIDAS Civil for the bridge analysis as well as design. Now, in the bridges, when it comes to tapered section groups, engineers feel it very convenient to use. So what do you do when you have to use the tapered section? You have to calculate the section properties at all the intermediate sections. So if you want a tapered section like this, so you will need to calculate the section properties at this section, at this section, at this section, and similarly at all the other sections. Now, using the MIDAS Civil, one can create the tapered sections very conveniently. So the program omits the need for calculating the section properties at all the intermediate sections. So the engineer needs to provide the information regarding the section property at the I end of the first element, at the j end of the last element. And then you can assign the tapered section group to all these elements. And then you will see that the section properties at the intermediate sections are automatically calculated by the program. Then for the use of the PSE sections, the program also supports the PSE Bridge Wizard. So if you are using the PSE Bridge Wizard, then you need to enter the information regarding the depth of the section varying with the longitudinal direction of the bridge. So you enter the distance of the longitudinal direction and depth at that section. In this way, you can create the tapered section. Using the PSC Bridge Wizard, you can vary not only the depth of the section, but you can also vary the width of the section, the web thickness, as well as the flange thickness. Now let's see some of the modeling features in the program. So here I have a model file. Here I have defined some materials for the concrete as well as for the tendons. And then I have also defined the time-dependent material properties for creep and shrinkage. So for the creep and shrinkage, I have selected the AASHTO code. And then we need to enter some required parameters like relative humidity and age of concrete at the beginning of shrinkage. And then we need the volume surface ratio for each element. The program supports the auto calculation of this volume surface ratio for all the elements. So we have the results for the creep coefficient and the shrinkage strain. Then I have a predefined tendon property. Now let's see how we can use some general modeling features of MIDAS Civil. So apart from the wizards for the bridges, the program offers a very user-friendly general modeling. So here I have a bridge. So I'll use the beam wizard. So I need to enter the information regarding the spans. So as soon as I enter this information, after that I'll need to select the material as well as the section. So as soon as I entered the information, I have the bridge model with me. Now I need to connect the supports to the bridge deck. So for that, I'll be using the elastic links. So now I need to create the elastic links at the 4 locations. So I can simply create the elastic links at one location and the program can copy those elastic links to the other locations. So I created one elastic link and 3 are automatically created. Similarly for this position. Now we need to have tendons for the deck. Let's see that how the program offers the tendon input information. So the program offers the manual definition of the tendon profile. For the manual definition, the program has the various reference axes. For the tendon definition, you can use the straight reference axis. We can also have the curve reference axis, and we can also input the coordinates of the tendon with reference to the center line of the element. Also, the program supports import and export of tendon profiles with the DXF format. So we'll see that how we can import and export tendons from the DXF format. So for that, we need to go to Tools and Tendon Profile Generator. Here I'll locate my DXF file. And then I need to enter information regarding the material property and the elements where I want my tendon. And then which profile is for XZ plane and which profile is for XY plane. And finally where the tendon should be inserted. And similarly for the second tendon. So as we will enter this information, the program will generate a text file for us. So we can copy the information of this text file in the MCT command shell and click on run. So we have the tendon profiles with us. So here the program created the tendons as they were defined in the DXF file. Now, if I have to manually copy these tendons, then that is also very convenient. In the loads and the temperature and pre-stress loads, we have the tendon profile. So we can select the tendon profile that we want to copy and then the location where we want to copy the tendon profile. So now we copied 2 tendon profiles and in total we have the 4 tendon profiles. Now let's see the application of the loads for this structure. For the application of loads, we need to have some static load cases. I have some predefined static load cases. So first of all, the cell width for the structure. For defining the cell width of the structure, we need the load case name and the direction of gravity. and the program will calculate the self-weight load depending upon the section properties as well as the densities for the material, and then the temperature loads. For the temperature loads, the program supports the use of the element temperatures. In element temperatures, we can assign the increase and the decrease of the temperature of the element, and then the temperature gradient, and then we have the beam section temperature. So we'll be using this today. So for the section type, we have the PSE section, and I need to enter information regarding the temperature at the various points of the section. So at the height of 1.22 meters, the temperature is 46, and at a height of 4.88 meters, the section temperature is 12. I need to select the load case. So as soon as I complete this, the section temperature is defined. Now regarding the reinforcement. So in the section manager, we have the reinforcement. So we can enter the reinforcement using the various formats, the point reinforcement, the line reinforcement, and we can even specify the same or different rebar data at the I and the j ends. So we'll enter the information for the top as well as bottom of the section. So we defined the reinforcement for the top. Now we'll define for the bottom. Okay, so the reinforcement is defined. And similarly, we can define the shear reinforcement. So for shear reinforcement, we need to enter the pitch, and similarly the torsional reinforcement. So we have the reinforcement in the section with us. Now let's see the application of the moving loads. So for moving loads, we need to define the moving load code. So the program supports the moving load code definition as per AASHTO codes, Canadian codes, British codes, Euro codes, Australian codes, Russian codes, Taiwan codes, and various others. So in order to take care of the codal provisions, the program provides several options which vary with the codes. Let's see. Here we have the lane support negative moment at interior piers options for AASHTO codes, and the lane support reaction at interior piers for the AASHTO codes. But if we see for Canadian codes, we do not have these options. So these options have been specially provided for the AASHTO codes, as the AASHTO code specified to take care of these needs. We'll discuss about these provisions in the coming. So for defining the moving load, first we need to have the traffic lanes. So we'll define some traffic lanes here. So the lane 1, and the lane 2. Lane 3. And the lane 4. So we have the definition of traffic line lanes. Then we need to select some vehicles. So you can have the vehicles as defined in the standard, or we can also have the user-defined vehicles. So we'll select 2 vehicles defined in AASHTO LRFD codes. And then we need the vehicle class. And then the moving load cases. So for defining the moving load cases, we need to select the lanes and the minimum and the maximum number of loaded lanes. Also, we can select that the loading effect we want to choose is independent or combined. In case we choose independent, the effect of these two will be considered independently, and if we choose combined, the maximum combined effect will be considered. So this is the standard definition of the moving load case. Now let's see some special provisions specified by the AASHTO code for moving load. So AASHTO code specifies to consider the effect of 90% of 2 design trucks spaced at 50 feet and 90% of the design lane load. So whenever we are calculating the design moment at interior pier, we need to consider this. So this can be easily taken care by the program. So here first we need to define a lane group. So assigning the structure group, the material properties, the section properties is made very convenient by the drag and drop procedure. So we just assigned a structure group, and then we need to select the structure lane group in order to take care of this recommendation by the AASHTO code. And then similarly we can do it for calculating the support reactions. So for calculating the support reactions, we need to specify that at what spans are nearer to the supports. So we have the node number as 25 and 44. So we'll add these as supports. Now, in this way, we take care of the provisions specified by the AASHTO code. Now, also for the moving load analysis, we need to have the effective width scale factor for the deck. So the program supports the auto calculation of the effective width scale factor. Also, we can have the manual definition of the effective width scale factor. Let's see the auto definition. So for the effective width scale factor, first we need to have the span information. And then we need to specify that where is the support located. So we have the element numbers as 16, 17, 35 and 36. At the J node of 16th element, we have the support, and at the I end of the 17th element, we have the node. Similarly for element number 35 and 36, the J end and at the I end. And finally for the element number 52, we have the support at the J end. So we have the span information. And then in the PSE bridge, we have the effective width. So we can select the effective width to be calculated as per the AASHTO recommendations. And then we can have the results for the effective width scale factor as well as the effective width. So we have a text report for this, and also the results can be obtained in a tabular format. So after this, our modeling part is completed. Let's see how we can control the analysis in the program. So some of the features of analysis control. So when we have the elastic shortening, then the tendon tension loss will be affected. I mean to say, when there is the elastic deformation due to live loads, then there will be the elastic when there will be elastic deformations due to live loads, then the tendon tension will be affected. So the tendon tension loss will change with the elastic deformations. So if we want to consider that change, we can opt using the analysis control. If we want to ignore that effect, that can also be done. Usually for preliminary analysis, we ignore that effect, and finally for the full detailed analysis, we consider this effect. Also, due to the creep and shrinkage, the tendon tension loss will be affected. So in order to consider that, we can check this option, and the program will take into account the change in the tendon tension due to the creep and shrinkage. And then we can control the stress over the transfer length in a post-tension model. So in order to use this, we need to define the transfer length in the tendon profile. So we can choose that we want to have a constant stress in the transfer length, or we want the stress to be varying linearly. Here we see that we have a tendon and a member, and near the anchorages, the concrete will crack, and due to this, the stress in the tendon will be reduced, and we can consider this effect. And then we can also consider the presence of tendons for calculating the section properties. For calculation of the section properties, the program can consider the presence of the tendons. In case of post-tension, we can use the net section with the duct areas excluded before the grouting. And then we can use the transformed section with the duct areas included after the grouting. Now let's see some of the result features. So for results, as we have the construction stages with us, so the first construction stage, the second construction stage, the third construction stage. So as soon as we compose a construction stage, the program creates the load cases for tendon primary, tendon secondary, creep primary, creep secondary, shrinkage primary, and shrinkage secondary. So we can view the beam diagrams for these load cases. So let's see the beam diagrams. So here we have the beam diagram in the fourth construction stage for the dead load. Similarly, we can have for the tendon primary and tendon secondary. Also, we can choose to have the current step forces. So we can see the forces produced in this construction stage only. Then the results are also available in the tabular forms. Also, with the results of the construction stages, the program provides the envelope of the construction stages as well. So for the envelopes, we can choose the min-max. So here we have the results in the tabular forms. All these tables are compatible with Microsoft Excel. We need to select export to Excel and we can have all the results in an Excel sheet. Then for the result of tendons, we can have the tendon losses. So here the program will calculate the stress after immediate loss and the loss in stress due to elastic deformation and the ratio of the both, and then the loss due to creep and shrinkage, the relaxation loss, and finally the stress after all the losses. So we can choose the construction stage and the tendon, and then we can view the results. Also, these results are available in the form of forces. Then we can also have the tendon loss graph. So for tendon loss graph, we need to select the construction stage and the tendon, and we can get the tendon force varying with the distance. Also, we can export this graph as image or as text. Then we also have the camber results with us. We'll discuss about the camber results in the coming slides. Now, for the results of the moving load, the program offers a moving load tracer. So in the post-construction stage, we can view the results from the moving load tracer. So here we can select that for which element we want which component to be maximized at which part. So here we see that we have the results for the moving load tracer. So the program displays the location of the vehicle for that specific situation, and also we get the maximum value so we have the results with us. Then we can also view the results for the moving load tracer in the beam diagrams in the post-construction stage, also in the form of tables. So here we need to select the moving load cases, and we have the results with us. So here we have that for the moving load MVL1 max and for the element number 25 at the part I, we have the maximum shear Z to be equal to this value and the maximum torsion to be this and the maximum moment in Y direction to be this. But all these effects may not be occurring simultaneously. So for that we need the concurrent reactions, concurrent forces. So we can easily view the concurrent forces using the view by max value item. So here we have the concurrent results. So this result means that when my shear Z is maximum, then for that situation the torsion is this much and My is this much. So the program supports both the results. Now, this was regarding the result features. Now, let's see the designs. So for design, we will be using the specifications of AASHTO LRFD. So the code specifies to have the ultimate limit state check for the flexural strength, for the shear strength, for the combined shear and the torsion strength. Then we have the serviceability limit state checks. So for the flexure design, the program calculates the stress variation and the nominal moment. Similarly for the shear design. So let's see the design features in the program. So first of all, for design, we need the load combinations. The program supports the auto generation of the load combinations. So here in the load combination dialog box, we have various tabs: the general tab, steel design tab, concrete design tab, and SRC design tab. So the combinations required for PSC design should be generated in the concrete design tab. So here we will auto generate the load combinations. So we want to generate the load combinations as per AASHTO standard. So as soon as I click OK, the program will create the load combinations. Also, we can have this information in the terms of spreadsheet. So this makes the editing of the load combinations very convenient. And also we can export this information in the terms of load combination sheet. So we have the load combination with us. Now we will move to the PSC tab for the PSC design. So first thing we need to specify is the design code to be chosen. So the program supports the AASHTO code, the Canadian codes, European, Russian, Korean, Japanese codes for the PSC design. And then we need to select some of the parameters to control the design. Let's see how we can make the design using these parameters, how we can control the design using these parameters. So here we have the exposure factor selection. So we can select the exposure factor as per the AASHTO code, and also we can manually input the exposure factor. Then we need to select the corrosive condition, and then we have the flexural strength selection. So in order to calculate the tensile stress in the tendons, we can use both the code as well as the strain compatibility. Now if we select code, the stress in the tendons will be calculated using the equations provided in the code. So the code provides equations for all the situations for both bonded as well as unbonded tendons. But when it comes to strain compatibility, we can use the strain compatibility for the bonded tendons. The strain compatibility is not applicable to the unbonded tendons. So if we have the unbonded tendons and we select the strain compatibility, then the program will automatically calculate the flexural, the stress in the tendons as per the codal provisions. And then we can specify the construction type to be segmental or non-segmental. In case the construction type is segmental, then the governing design forces will be at the joints and not at the sections. And then we can select the design positions. So if we have a very large model, then we can choose a very few positions to be defined, to be designed for movement as well as shear. But here I have selected all the positions for the PSC design for both movement as well as shear. And then we can choose the output positions. So we can select that at what positions we require the design report. So once I'm done with all this information, we can start performing the design. So as for the results of the design, we'll be getting all the tables for the limit state checks. Also, we will be getting the Excel report at the specified output locations. And then we'll also have the PSC result diagram, which is a very useful tool. So in the message window, we have the information that the PSC design is completed. Now let's see the limit state checks for both ultimate limit state as well as the serviceability limit states. So first of all, we will see the serviceability limit states. Now, when we have the time varying compressive strength, then the allowable load changes with the compressive strength. So for every construction stage, for a particular section, we will be having the different allowable strength. So for that, we need to ensure the safety of the structure. So here we have the results with us. So how the program ensures the safety of the structure is that the program calculates the ratio of the required stress and allowable stress at all the construction stages for all the sections. Then whichever ratio is the highest, the program chooses that stress to be compared with the allowable stress. So the program calculates the stress at the top fiber, the center top, at the bottom top, at the center bottom, at the top left, at the bottom left, at the top right, and at the bottom right. So whichever stress comes out to be maximum, that is compared with the allowable stress. And then we have the check for the tensile stress in the tendons. So here the program calculates the stress in the tendons. So FDL1 is the stress in the tendon at anchorages. FDL2 is the maximum stress in the tendon along the length away from the anchorages. And FLL1 is the stress in the tendon after all the losses at the last stage. And then the program also has the allowable stresses for these. So we have the comparison between the allowable stress and the actual stress. And then third is the check stress for the cross section at the service loads. So here the program calculates the stress using the service loads. So the program calculates the stress for the center top, center bottom, top left, top right, bottom right positions, and then compares the maximum stress with the allowable stress. And then we have the principal stresses at the construction stage. So the program calculates the stresses at the 10 specified locations. So, and then compares the maximum stress with the allowable stress. Similarly, stress for service loads, excluding the torsion shear stress, and then also the combined shear stress, the principal stress. And then we have the check for the crack width at the service loads. Let's see how the check for the crack width is applied. So here the program compares the spacing of the rebars and the maximum allowed spacing of the rebars. So we have the results for the combined stress due to bending moment about the major axis and the axial force at the top fiber. And similarly, we have the results for combined stress due to bending about major axis and the axial force at the bottom fiber. And then these are the tensile stresses in the reinforcement. And then the spacing we specified for the reinforcement and the maximum allowed spacing. Also, I would like to mention that for the PSC sections, the program offers the beam stresses. Here we can specify the position as well as the component to be displayed. And then we can get the stress diagrams. I should have mentioned it earlier when we were discussing about results, but I forgot and I'm sorry for that. So here we have the beam stresses. So we can select the 10 specified output locations and then we can have the stress diagrams. Now, for the design force, we can have the tabular results. So for all the elements, we can have the design forces. So here we have the results. So for element and the load combinations, we have all the results with us in the tabular form. And now we can see the PSC result diagrams. this is a very useful tool for the PSE design. The tool offers to check the ultimate force and the criteria force at once. So here in the diagram, the green line mentions that this is the allowable force, but the ultimate force is less than that. The actual force is less than the allowable. So we can very quickly verify that our forces are appropriate or not. And then we can also have the results in the form of the safety factor. So this is the criteria line for a factor of safety of 0.6. And then finally we can have the Excel report of the design. So for the generation of the Excel report, we can use the units to be standard units or the US units. The Excel report will be generated for the elements that we specified in the output position. I have a pre-generated Excel report with me. So in the Excel report, the program provides all the tables for the ultimate limit state as well as the serviceability limit states. All the checks for the serviceability limit states are in separate sheets. So first we have this stress at the construction stages, and then for the stress check for the serviceability load combinations, and then the principal stresses. So these are all the serviceability limit states, and for the ultimate limit states we have the detailed design report. So in the design report, first we have the information regarding the design code, then the section properties, then the material properties, then the pre-stressing steel, and then we have the sectional forces due to effective pre-stress, and then we have the flexural design for the section. So we have the axial force in concrete and the axial force in the reinforcement steel for both tensile as well as the compressive zone, and then the axial force in the tendons, and the calculation of the flexural resistance. So whenever there is a calculation for the flexural resistance, the program will also mention the specification number in the code. So you can manually verify the results, and the manual verification is very easy when you know that from where what thing is coming. So for that we have provided the specification numbers in the report as well. And then the shear design. So we can have the shear design, the calculation of the effective depth, the maximum spacing of the transverse reinforcement. So with every check we have the specification number mentioned. So it is a very detailed report. And then the torsion design for the section. And then the crack check. So we have the reports for all the output locations specified at I node of the 16th element, at the J node of the 16th element, and similarly we have all the results with us. Also you can perform the peer design using the program. For the peer design you can get the PM interaction curves, and you can also get a very detailed report for the pier design and the graphic report. Now let's see some of the other features in the program that assist the bridge engineers. So first is the wizard for the transverse analysis. So here what you can do is that you can specify an element for generating the transverse analysis model and input the information regarding the load and the reinforcement, and then input the definition regarding the load parameter. Then the program will generate a model for the transverse analysis of the section. Then if you want the full 3D modeling, then you can use MIDAS FEA. So MIDAS Civil can communicate with the MIDAS FEA, and the geometry in MIDAS Civil can be exported as the solid in FEA. So in this way the geometry is automatically generated. And then the grillage model wizard. So the grillage wizard automatically generates the grillage model. It also generates the longitudinal members, and also you can specify the location of the transverse members. And then the FCM camber. So the camber is very important for erection engineers. Whenever we are installing the bridge at the site, then sometimes we face the problem that the last segment is not fitting. So in order to take care of that problem, the program calculates the FCM camber. So the program can provide you with the camber control graph, and you can take care of the camber while installing the bridge. So let's see the camber results. In the results we have the camber. So we'll get the construction camber. So the program supports the calculation of the camber as well. This was all regarding the today's webinar. If you are having any questions, then please feel free to ask in the questions window. I guess I don't have any question. Oh. So. That is the transverse model analysis. If they want to, so transverse model was also beam element in that case. If they want to do the height also rate for the transverse model, they can use So we have some questions with us. So the first question is that how we can extract the bridge deflections for the each construction stage. So I'll demonstrate this. So for the extraction of the bridge deflections, we need to go to the particular construction stage and then select the deformed shape. So here we can select the load combination for which we want the deflections. So we can have the deformations. Also, this information is available in the form of tables. So we can select the appropriate load case, and then we can check the deformation results for the various construction stages. Also, we can get an envelope for all the construction stages. So this is in the tabular form. I hope this clarifies that how we can extract the deformation results for the construction stages. So then we have the next question, that if it is possible to transfer sections from the longitudinal analysis to the transverse model. So when you will be using the transverse section wizard, then the section created will be a line section. But if you want to have the modeling of the transverse section in using the solid plates, then you can use MIDAS FEA. So here from export options, you can export the frame section for model for solid, and then you can use the geometry generated in MIDAS FEA. Then we have an question that regarding the camber control. So I demonstrated the camber control in the webinar. So in order to take care of the camber, you need to manually adjust the location of the nodes. So next question we have that what is the use of the option the real displacement. So if we uncheck this option, then the program applies a scale factor for the deformation so that we can clearly see the deformations. But if we check this option, then the program will provide us with the real displacements in the bridge. Also, the program offers to see the stage step real displacements. So next question we have is that if we can perform the if we can reflect the effect of camber in the PSC composite design. So next question is regarding the design of PSC composite. So at the moment, the program doesn't support the PSC composite design as per AASHTO code, but the PSC composite design is supported as per the Euro code. And as per AASHTO codes, the program will be able to design the steel eye composite sections in the next release. The next release will be in June 2014. So next question we have is regarding the displacement due to the secondary effects of creep and shrinkage. So 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 for deformations, we have the creep primary and shrinkage primary results with us, but the secondary and the shrinkage secondary results are not required for design. So that's why the program doesn't support those results. So next question we have is that can we use PSC to model the cable straight bridges? So the software supports the use of PSC for the cable straight bridges. The next question is regarding the stage step real displacements. So I will like to use a picture for this, for the explaining this. So here we can see that in the different stages, we have the deformations in the structure. So the real displacement in the construction stage 3 at the point 3 will be the summation of the deformations in the first two stages. So using the real displacement option checked on, we get these displacements. So this option is activated after we check on the option in the construction stage analysis control. Here we need to check this option on for having the stage real displacements. So the next question is regarding the friction losses in tendons. So in the tendon property, when we specify the tendon property, we can specify the factors for the curvature friction as well as the wobble friction. So using these factors, the program calculates the friction losses. Questions, please feel free to write the questions in the questions window. So we think there are no more questions. So thank you all for attending today's webinar. So if you have any questions in the further, please feel free to write at yjkim@midasit.com. I will spell the email yjkim@midasit.com.